All right. Hello, everyone, and happy Friday. Today is August 14th, and this is episode 14 of our Google Hangouts and podcast on all things DOCSIS. I'm Brady Volpe, founder of the Volpe firm and Nimble This. Today we have news, updates from the proactive network maintenance meeting at CableLabs in Colorado last week. The SCTE Expo is less than 2 months away, and you have questions, and we have answers for those questions. With me today is John Downey, prognosticator of mini slots and consulting network engineer at Cisco Systems. John, how have you been?
My new title, prognosticator of mini slots.
So, you'll get a new one every week. So.
I can give you the forecast of how many slots are allocated.
Yes. Yeah. So you'll optimize. So we'll just we'll create a little web page. You can dial in, and we'll say, well, what should our mini slots be this week?
Appreciate that.
Yeah. So, hey, weren't you supposed to be traveling this week? You're.
I was supposed to be in Mexico, and it was postponed for a week. So, luckily, I didn't have to do a red eye last night, and get on this Google Hangout all literally red-eyed. So
you really don't look any better than normal. So I'm not sure that we'd notice a difference.
I try to set the expectations low, yeah. And I can only go up from there.
That's awesome. Yeah.
Same thing with all my presentations. Like you mentioned that the SCTE Expo is coming up. It's almost exactly 2 months, right?
Yeah.
It's like October 13, 14, 15, I think it is. I know you're doing a presentation, and I'm doing one of the workshops as well. What is your workshop on?
So mine is going to be on proactive network maintenance, which has kind of been a focus of mine for a while, but it's going to be sort of on, so you have proactive you have PNM now. What do you do to make it successful within your organization? So we'll be talking about PNM champions, some of the key things that you can do to have it be successful in your organization. So it's kind of that focus. We've kind of moved beyond the theory and stuff like that. Now it's, when the rubber meets the road, how do we move forward from there? So what's your presentation on?
So it's kind of like two titles, right? It's a workshop. The speaker, I'm reading it right now, speaker's presentation title, that's my title, is Managing DOCSIS Capacity over HFC Networks, DOCSIS 2.0, 3.0, and Future 3.1. So I'm trying to go more into the 3.1, and I give some examples of what could you offer with, and a migration steps of, say, 12 downstream to 24 downstream to 32 downstream single channel QAMs to DOCSIS 3.1, 192 megahertz OFDM block, and then multiple blocks. And at what point do you upgrade to, say, 85 megahertz on the upstream? Should you even think about a 204 megahertz upstream? If you're going to do that, you might as well go to 1.218 gigahertz downstream. There's another option for 3.1 of 1.719 gigahertz downstream, but I don't see that happening anytime soon. So it's kind of like, I like to be almost technology agnostic and talk about what are the pros and cons of all the different scenarios. Instead of us all just sitting back and analyzing, analysis paralysis, we're analyzing all these options and we're not going anywhere with it. We have to, draw a line in the sand and say, let's do something. And what would this get me? And why can't I do this? Or why should I do this? Blah, blah, blah. Well, that was the title of my presentation. The workshop session is titled DOCSIS 3.1 and IP Traffic Engineering, How to Stuff 10 Pounds of Stuff into a 5-pound bag. How to stuff 10 pounds of stuff. I would have just went right out and said shit.
Call in.
Exactly. We're all the cable industry, so come on now.
There might be one or two swear words attached just packing in, along with a couple adult beverages. So it's in New Orleans, anyhow. So.
Might see me on Bourbon Street one of those nights, the night before my workshop, and of course, you know how the workshops are probably 8 a.m. after the party. So we'll see how it goes.
Yeah. Well, I think I'm going to be doing one of those breakfasts, like the 7 or 7:30 a.m. breakfast, and I'm just, oh no, that's going to be brutal. So,
good luck with that.
Yeah.
I won't be there.
Yeah, sure you will. So we're looking forward to that. That's coming up. In the news, so that's one of the in the news items. other things that's happened since our last presentation is FCC did approve the merger of AT&T DirecTV. So what makes that interesting is AT&T is now the world's largest, so I want to say this right, largest pay TV provider in the world, because they have 26 million customers in the United States and Latin America, which makes them larger than Comcast. Comcast has 22.4 million subscribers, which this was from their March statistic on them. So that they're the largest data and video provider in the world right now is AT&T with this merger. So that puts them in an interesting position.
Definitely. What I mean, if Comcast Time Warner merger would have went through, that would have been what, 36 million or something crazy.
That would have made them the largest. Yeah, that would have made them a mega merger. Which there's kind of that I don't know if that's the reason that the FCC didn't let that go through. Interesting though, the FCC put a lot of stringent regulations on AT&T. They said that, of course AT&T must abide by net neutrality rules, so they can't provide preferential treatment to any particular data traffic or anything that they're affiliated with. They must debundle data and video services, especially to low-income subscribers, and they have to offer a 3 to 10 megabit megabit per second data tier for low-income subscribers at a really reduced rate. And we don't know what that reduced rate is. There's rumors that it's going to be like around $5 to $10 a month. So that this is kind of like, for that merger to go through, they have to offer that. They have to be transparent in disclosing their interconnection agreements with where they're getting their different data bundles through on our edge providers, and they also must report their network performance on some regular interval, so that they can say, yes, we are providing good data to their subscribers.
Or we're providing what we say we plan to provide. Just proving proving that you're providing it. Now, what's interesting about that is I kind of read in between the lines, and I listen to wording literally sometimes. And when you say low-income subscribers, what are they going to do? Look at their people's tax returns? Make sure you're not making too much money? Well, you made too much money, so you can't sign up for the 3 to 5 megabit per second service at $10 a month. You must subscribe to my 50 megabit per second service at $100 a month.
I wonder how they regulate that. I mean, if you're a college student, can you get this 3 to 10 megabits per second for, depending on how you do that? So it will be interesting to see how they do that, because there's likely to be a lot of people who will be able to qualify for this tier of service if it's available. So,
and if you're a college student, you can't be qualified as a dependent on your parents' tax return?
Well,
what is a subscriber? A low-income subscriber?
Yeah.
Is it an independent or a dependent? What does that mean? I'm still up in the air there. I mean, because it sounds too good almost. Like, what if I don't use very much? I'm like, I wish I could get internet service for 3 to 5 megabits per second for $10 a month. Who wouldn't want to get that,
Yeah, for an extremely low price, because that's really nice. So I think those were some of the concessions it looks like that AT&T had to make in order for that deal to go through. But it makes them a big player. So
is it 26 million? 26 million?
The number they have. Look at my list here again. It's 26 million customers in the United States, and another 191 million customers in Latin America is what more than 191 million customers in Latin America, including Mexico and the Caribbean. So that's a lot.
Yeah, no kidding. And what about the Charter Time Warner merger? Assuming that goes through, I assume that gets Time Warner Charter closer to Comcast, right?
I would think that'd make them very competitive with Comcast at that point. I haven't looked at what those numbers are, but that's going to be a large operation if that goes through as well.
It's an interesting trend because you probably also heard about the French company called Altice. and they're buying up a few companies here and there, and they just bought up or buying up Suddenlink.
Yep.
So it's interesting to see Liberty Global buying up companies in Latin America also, and it's kind of opening up not just within, say, one country, but across countries now. I think we have a Canadian company, maybe I think it might be Cogeco or Videotron, that bought Atlantic Broadband. I don't know if you're familiar with ABB.
Yeah, I am, but I didn't know that acquisition that occurred.
That was that was a couple of years ago, I think. I think it was low. Many people didn't realize it.
Well, yeah, but Atlantic Broadband still exists, or I mean, it's under that name. Yes. But I didn't know they were owned by a Canadian company.
Yeah, and I wanted to say Cogeco or Videotron. Now I can't remember which one. But yeah, it's interesting because now we got, companies outside the U.S. buying MSOs or cable companies within the U.S., which is kind of interesting.
So it's very common in the industry right now for these acquisitions to be going on. So another thing that happened in the first week of August was if you're familiar with the DEF CON, the Black Hat DEF CON conference it happens every year. It's held in Las Vegas, and they have shows throughout the world, but this one is one that notoriously we've oftentimes had DOCSIS coverage on how to hack cable modems, how to hack DOCSIS networks and stuff. The good news is this year we didn't get any coverage. There was nothing on how to hack cable modems, or nothing new on that end. The bad news was there was a lot of coverage on how to hack Internet of Things devices, IoT devices, and also how to hack Wi-Fi. There's a lot of Wi-Fi exploits. So that does impact us just because those are all endpoints that are on the end of our cable modems, so to speak. And to some extent, the Wi-Fi devices are right in our cable modem. So there were coverage on things like Wi-Fi access points that are part of cable modems. The thing that we used to be concerned about before was WEP hacking. WEP cracking. Now they're finding ways that you can, and for some time that crack WPA, but there's been a number of security exploits that they found just in Wi-Fi routers in general. And I noticed in the month of July there were a number of known cable modem vendors that came out with security fixes, which are basically firmware downloads to the cable modems. So I would recommend that everyone kind of check with your cable modem vendor and find out, do they have a latest firmware update for the cable modems for the Wi-Fi portion? Because of course that's included in the download. That's going to cover a lot of these patches that were discussed at the DEF CON conference. And maybe unrelated to the DEF CON conference, but there have been a lot of exploits in the wild for Wi-Fi side of things on cable modems and just Wi-Fi in general.
So you're talking more of sniffing or cloning, not just blocking or denial of service, jamming, nothing of that sort. You're actually talking about getting into the wireless, decoding it, or figuring out how to steal information.
Yes, so there's a couple of critical things that are going on. I mean, one is just getting access into the subscriber's home. The one that's actually more critical is more of a man-in-the-middle attack. So people are getting access to the Wi-Fi access points, and then they turn them into a man-in-the-middle attack. So you think that you're going to a site that has encryption, that has an SSL certificate, which means it's HTTPS encrypted. But once they've accessed your Wi-Fi router, they are able to see what's going over what you think is a secure site. So you're doing your banking, or you're going to Amazon.com, and you think everything's encrypted, but they are actually able to get all of your credentials once they've compromised your Wi-Fi router. So it's actually pretty serious. Because you think, hey, I'm safe. I'm in my home. I'm doing banking information over HTTPS, which is a secure encrypted transaction. But because the router's managing that, this is a man-in-the-middle attack. And now they're able to get your banking credentials, your Amazon username and password, and send that back to a server somewhere. And now they can log into your bank, log into your Amazon account, your eBay account, and do whatever they want with it at that point.
Yeah.
So this is really pretty severe what they can do with that type of information. So
that's good info.
Update your Wi-Fi router firmware, update, as cable operators, update your cable modem firmware update to update that router firmware if it's attached to the cable modem, and keep an eye on that stuff. Always use secure, strong passwords. Two-factor authentication, really highly recommended, because that way, if there is something, someone logging into your bank, your account somewhere, you'll get notification. You'll have to be required to authenticate from your phone via SMS or something if it's coming from an IP address that you've not logged into before.
So more of the story is change your default user password from admin password.
Absolutely.
or admin change me. One of those.
Yeah. Admin.
Yes, there you go. Another good one. Or the old one was Linksys or Cisco 123.
Yeah.
Or just Cisco.
Yep. So last week, last Thursday and Friday, we had a face-to-face meeting for the PNM, the Proactive Network Maintenance Working Group, called Ingenious, at CableLabs headquarters in Louisville, Colorado. And the goal was to bring everyone together that's actively using some of the PNM software from CableLabs, or those of us who are working on PNM software applications, and start updating the PNM best practices document that CableLabs has put together. And we did actually talk about this, this document, sort of who reads it, what's its intended purpose, and we kind of agreed that it's read by a lot of people that are programmers that are trying to figure out how to interpret pre-equalizer coefficients and stuff like that, and the things that we're going to be adding to the document that was not previously in there are things like how to do upstream spectrum analysis using the CMTS, how to do downstream spectrum analysis using the cable modems, how to do things like detect intermittent cable modems in a network, detect where ingress is coming into the plant in the network, how to practically understand. So, we talk about echo cavities. We talk about things like TDR distances in the PNM best practices document. We don't necessarily talk about how to actually go out and find those, maybe using leakage detection meters and stuff like that in the field. So we're going to update those documents with all the things that we've learned about in the last several years since that document was last updated, and put a lot more of the practical things, the new things that we've learned about in the last several years. So
nice. I talked to Ron Aranek, who I know was out there also, and he did mention one of the things was interesting is Comcast is very aggressive in implementing the newer 3.0 modems out in the field that have all these features. So the more endpoints we have, the more test points we have. And if they have full bandwidth capture, then you basically can do, if you have full spectrum of analog video, digital video, DOCSIS, everything is full, there's no need to inject sweep points. You already have a sweepless sweep. You already have all the channels there. You can pull the modem for its spectrum analysis. And if you see standing waves, just like we do the calculations on the upstream pre-equalization standing waves and frequency response to find out these cavities and the problems where the impedance mismatches occur, we can do the same thing sort of on the downstream, right? We can look at the downstream spectrum analysis, do some mathematics on that trace, compare one trace to another trace, to one modem or another modem, and start narrowing down where we think the problem might occur or coming into.
Yeah, that's exactly right. And part of this, so when you talk about seeing a standing wave in a downstream, part of what we need to update in a document is educating people on, you see that standing wave, how do you make the calculation, which is not a very complicated calculation, but how do we make the calculation of turning that standing wave and turning that into a distance in feet or meters, depending on what system you use.
And what does that mean?
And what does that mean? Where do we figure out where the impairments are? How do we look at maybe multiple homes that are seeing the same standing wave and then back that out into a correlation group? How do we look at other things that we see in that full band capture, things like suckouts, tilt, adjacent channels that, maybe you have your DOCSIS signals at one level and your video signals at a different level, and say, well, I have something in my head end that's not balanced properly, and then take action on that. So, I mean, these are all things that we understand when we see it maybe in the head end using a spectrum analyzer. But now that we're using full band capture modems in a subscriber's home, say, okay, this is something I can go back and fix in the head end, or this is something that's probably in an RF amplifier because it's maybe a peak, a resonant peaking thing that, something we saw back when we worked at C-Core years and years ago. And or maybe it's a suck out that could be in the outside plant, or could be even in the subscriber's home. So there's lots of things that we, kind of like a library that we need to create and say, what do each of these different signatures mean? And when we have them, where do we look for them? And how do we take action on them? Because the number of DOCSIS 3.0 modems that have full band capture is just increasing so much. And now we're, first we'll show people, if you're not already doing this, here's how you do it to get the data from the full band capture modems. And then once you have the data, here's how you interpret that data to do something meaningful with it, to tell your technicians, here's a problem, go fix it. And here's where you should look for the problem.
Yeah, I was talking to a few guys from Comcast that deal with the PNM stuff quite a bit. And I asked them, I said, are you also looking at the upstream spectrum analysis in the modem? He said, yeah, it's just a matter of, well, the modems they have deployed, do they even have that functionality? Maybe not, because Broadcom, like you mentioned from one of your last trips to CableLabs, I think it was in Atlanta, the winter conference maybe.
Yes.
Where they announced the upstream spectrum analysis. When we first talked about it, I thought, what good is that, right? What good is it seeing the noise at the house when it doesn't, when all the noise funnels back to the head end? So I want to see all the noise at the head end, but if I can see the noise in an individual house, maybe that matches up with the head end, so I know exactly where it's coming from. So I sat back and thought, well, how would I do divide and conquer troubleshooting? How would I look at one leg of a node to see if the ingress is coming in? Normally, you would probe a port and look at a spectrum analyzer. You see ingress coming in and say, there it is. But how are you going to use this modem information? And as I talk to those guys, I think what's going to happen is they're polling the modems all the time anyway. It's not like I'm going to have to instantaneously poll each modem and say, all right, where's the ingress coming from? I could look at my historical data gathering and see where the ingress was coming from, assuming that it captured the ingress at the time I did the polling. Because it could be impulse, very intermittent.
So when I did the when I was at CableLabs at I think it was the winter conference that was in Atlanta, that particular version of Broadcom modem that I was doing the testing on, that was their latest one that they did not have the diplex filter in, or at least in that particular modem, they were able to look at the noise floor from 0 megahertz up to 54 or whatever. Basically, you could see the noise floor really nicely.
Yeah.
What they've done now is they came up with another firmware update so that a lot of the existing deployed modems out there, at least for the Broadcom modem, I think Intel has also done the same thing, that have diplex filters in them. So you have this diplex filter in a modem, and what that means is you have a lot of attenuation from 0 megahertz up to 42 megahertz, wherever the diplex filter is rolling off. That means you can't see a lot of the ingress noise from 0 to 42 megahertz. But what they did is they collected data, and we got to see this data, cable modems, off of a couple of 100,000 modems. And they would look at the noise, the ingress coming from homes just above 42 megahertz. And it was amazing, between 42 megahertz and wherever the just above 42 megahertz. It was amazing. You look at 100,000 modems, or a couple 100,000 modems, how much noise you can see just above that diplex filter, and then make assumptions based on that, where you look at 200,000 modems and you say, okay, out of these 200,000 modems, we can see a few % of them that the noise floor just above 42 megahertz is significantly elevated. And then roll trucks based on that and find out in those homes where the noise floor above 42 megahertz is significantly elevated, everyone, a large percentage of those homes had significant ingress leaking out into the plant. So even at that, like you're saying, well, you're worried, we're not going to. It's way, way better than nothing. Absolutely.
Yeah. It's like using the full bandwidth capture that's on the high side of the diplex filter to look at upstream, even though it's going to be attenuated from the high side of the diplex filter. Now, the newer feature that you were looking at also was, I talked to some Broadcom guys at the INTX show in Chicago, and they said, just by walking through the hallway, we were talking about, we have an extra FPGA. What do you want to do with it? I said, hey, we could activate it on the low side of the diplex filter. They're like, let's do it. So it wasn't any big master plan. They just activated it, and so after they did it, they're like, this is not a bad idea. If I can have a spectrum analysis on the upstream and the low side of the diplex filter, any noise that comes from the drop cable and the house will show up in my modem, and I can read it from anywhere in the world, like SNMP, and I can see. You're talking about added white Gaussian noise, a high noise floor, but if I want to look at ingress or maybe real-time polling and see maybe, I don't want to say impulse noise because that thing's not going to be fast enough probably to pick up 10 microsecond impulse noise. But if I have it a peak hold on, maybe I can capture steady state ingress like ham radio, shortwave radio, CB,
or HPNA, or other really high level signals that are there for long periods of time that are plaguing you.
Yeah. So, I mean, like we talked about, we keep doing this every Google Hangout. The more of these devices we have in the field and the more control or visibility we have, the more troubleshooting we can do. I was even thinking about, you talked about the levels of the digital and the analog, and it used to be back in the day, the head engineer would have to check levels every morning just to make sure every digital level was about the same level coming out of the head end. Well, if we're already looking at the levels of every single modem, we could probably say, well, every modem in the service group right here seems to be off. Well, if they're all off, then it's probably at the head end, So this gives us just more visibility to maybe decide which hubs and head ends we have to start tweaking to maybe get our levels in line. I mean, it could be other things too, right?
Yeah, definitely. So we have a bunch of questions in the mailbag. Is there anything you want to cover before I start on the questions and answers that we have lined up?
No, shoot. Go ahead. I know we tried to answer some of these already, but I haven't looked at them in a while, so we'll ad lib.
So we have a question from Nikish that says, regarding partial mode of a cable modem, what are the causes behind the cable modem going into partial mode, and how do we rectify this problem? So,
was this upstream or downstream, or did he say?
I think we can just cover partial mode in general, and I know we've covered this way in the past in one of our hangouts, but I think just covering what partial mode is, describe what it is, and then generally what
it's actually it's a good question, because I think since then I may have even come up with more information that I wasn't even aware of. The downstream partial mode. And DOCSIS 3.0, the modem locks, let's say I give you an example of 4 downstreams, 4-channel bonded modem. It's only locking on one of those downstreams as a primary, right? And then it's bonding across all 4. So, you get the added benefit of more speed. But that one downstream, if you lose it, you lose downstream sync messages, you lose DOCSIS, you lose timing, the modem goes offline, starts rescaling downstream again. Now, let's suppose you don't lose the primary, but you have a suck out at 609 megahertz, and that's actually one of his secondary channels, meaning he's locked on 603 megahertz, which is his primary, just for this example, and he loses 609, which is a secondary channel. The modem, according to the spec, is supposed to send a CM status message back to the CMTS, and then the CMTS can decide if certain configurations are done and certain features are set up that I can put him in a dynamic bonding group. So I have 2 choices. I can either make him re-register and drop to the primary channel only, and maybe I can do that dynamically where he doesn't re-register, so all of his traffic gets sent down the primary. So he's not bonding at all. But in that case, I can mark him as partial online, and when that downstream gets reported as good again, I can put him back in 4-channel bonding. The other option is I put him to a subset bonding group. So I drop him from 4-channel bonding to 3-channel bonding. So I dynamically make a bonding group just for that modem. I say, hey, I noticed 609 is bad, so you can use the other 3 channels for bonding. So now I push all his service flows to 3-channel bonding group. So here's the interesting thing I just learned not that long ago was the CM status message itself is not as robust as I thought. It's not a three-way handshake with acknowledgments from the CMTS, which means if the cable modem has an event and it reports that event to the CMTS, but for some reason the CMTS doesn't hear it, that might never happen at all, meaning the cable modem won't keep reporting the CM status event.
Now, when you're saying CM status, I'm thinking ranging, but I think maybe I'm missing what you're talking about, a different status message.
Yeah, so we can process, there's QAM lock status message, there's battery mode status message, there's QAM unlock, QAM lock. There's like,
okay, so it's the
like
status,
10.
it's the mode or the current status that the modem is in, like you know, initial ranging, init R1, init R2. It's the different mode, or the, you know, up to registered. Is that the,
But this is after registration.
Okay, this is after it's
after registered. So it can report if the QAM has become unlocked. It can report if the QAM has relocked. So when a 3.0 modem is registered and online and something happens, the downstream goes down, the modem goes into battery backup mode, that will generate a CM status message back to the CMTS, and then it's up to him to make the decision what to do with it.
And when do these status messages occur? Are they part of the ranging process, or is this a completely separate process?
I'm not entirely sure. I'm not entirely sure if it's part of my, you know, the keep alive every 15 seconds or not. No, it wouldn't be. I believe it's, I have to look that one up again, to be perfectly honest. But either way, my point is, what happens if the cable modem does have an event? It reports it back, because it has to report back on the upstream, and the upstream happens to be noisy. So I end up losing that burst. I know in the Cisco CMTS, by default, the cable modem will send twice in like 5 seconds or something like that. We have a certain settings for how many times and how many seconds. But if I lose both of those messages, the CMTS doesn't know he had an event. And the cable modem will never report it again until a different event occurs. So that modem could have an issue with one of the frequencies and not go into partial mode. And it's just dropping all its packets on 609 because there is no frequency at 609. So the CMTS is still sending packets down 609. You understand?
Yep.
So I thought it was kind of interesting. I think in 3.1, DOCSIS 3.1 spec, they were adding, I haven't looked at it lately, but they were going to add a like an acknowledgement, like a three-way handshake for this CM status message. That way you knew it actually did occur, or the CMTS did see it.
Okay.
Which to me makes a lot more sense. So because I've had issues where the modem reported an issue, CMTS put it into partial mode, then the modem reported the QAM came back, but that message got dropped and the CMTS never heard it again. So the modem stayed in partial mode forever. So then every night I would have to go through the CMTS potentially and say, let's look at this modem, let's look at the RF quality at the modem. There's no problems. Maybe I can take it out of partial mode manually. Maybe I can write a script or a test command to take it out of partial mode.
Yeah, so I mean, the partial mode is normally caused by an RF impairment, and I know with older iOS firmware, once that modem went into partial mode, even when you remove the RF impairment, the modem would be stuck in partial mode. So the only way to get the modem back on partial mode, out of partial mode, once you've fixed the RF impairment, would be to reboot the modem. Is that something that now it will self-heal itself? Say you remove the RF impairment, the CMTS will detect the impairment's gone, and now the modem will come back out of partial?
Yeah, way back in the day when wideband and DOCSIS 3.0 first came out, we didn't have, at least for Cisco side, we didn't have a feature to track the CM status messages I'm talking about. Like you might be confusing the CM status with like init R1, init R2, and stuff like that, but I don't think it's the same thing. We have a command.
I'm just confused, man.
You figure if we're confused, everybody else is confused too.
Yeah.
So we have a command on the CMTS that would activate the the listening of these CM status messages and make decisions on it. So you're thinking about old iOS where we didn't have the command, we didn't have the feature. Modems would fail their MAC domain descriptor and just drop offline and register traditional DOCSIS.
Right.
So they wouldn't be W online, they would just be online only. And then they would never go back to W online unless you reboot them.
Right. Yes. That was a pain.
Yeah. That was the old way. The new way was put the modem into partial mode. It would actually report P-online. And the even better way is push it to a subset bonding group, mark it P online, but then take it out gracefully whenever it tells me that everything's good again. So it's self-healing. Yes. And that's downstream. That's downstream. So downstream is it is what it is. Upstream is actually easier because all the traffic on the upstream goes back to the CMTS. So the CMTS knows what's going on in every single upstream channel for that modem, for every single modem. On the downstream, you have to poll the modems to know what's going on. And this is why we're requiring the modem to report a CM status message back, because we don't know what's going on. On the upstream, we do know what's going on. The CMTS knows every upstream, the FEC, the uncorrectable FEC, the MER of every upstream, every modem, you name it. So if a modem loses station maintenance on an upstream channel, more than say 8 times, we have some certain settings that you can manipulate, then we can mark that upstream channel instead of STA as doing station maintenance and stable, we can mark it as DR, which means disabled with ranging continue. We can mark an upstream on a upstream bonded modem down, and when it reports its back, we'll keep trying to range on every 15 seconds or so, and it reports its back again, or MER is good again, we can put it back to STA mode, which puts it into full bonding. So because the CMTS allocates the mini slots, so here's my prognosticator of mini slot title. When the CMTS allocates mini slots, it can say, you know what, that modem A, his upstream 1 looks bad, so I'm just going to allocate mini slots in upstream 0, 2, and 3. So hence, I just put them in 3-channel upstream bonding instead of 4. So it's much easier to do upstream than it is to do downstream.
And I will say, the same thing used to happen in the upstream with the older iOS software, where when a modem would go into partial mode in the upstream, you'd fix the upstream impairment, but that modem would stay in partial mode until you rebooted it. So this is another thing with a newer iOS firmware, and why I really recommend customers stay on contract with Cisco or with any of their firmware vendors. Keep getting that new iOS software and installing it on the CMTSs, because it really, really helps improve the performance of the plant. If you're on an older version of iOS software and your modems are getting stuck in partial mode, even though you're fixing the performance of the plant, it's going to stay there until you get a newer iOS, because these features are constantly being added, and it really, really improves the performance of your network.
So let me add one more tidbit, and you'll appreciate this because of all the work you and I have done on mod profiles and knowing the difference between the bursts and the request burst, IM burst, station maintenance burst, A long, A short, AUTS, all that. Because the partial mode is being based on this, and if that station maintenance burst in your mod profile is still QPSK, you could have this window that I call no man's land, where nothing happens, but you drop all your packets. Let's say your MER is between 13 dB and 23 dB. If your upstream MER is 20 dB, the QPSK station maintenance will still work fine, and the modem will never go into partial mode. But your 64 QAM is going to drop all day, so you're not going to get any traffic.
Yeah. So I mean, just to reiterate this one more time to anyone who's listening, please, please, please change initial station maintenance and station maintenance, which is your modulation profile 3 and 4, to 16 QAM. I mean, John's just giving you another reason why it's going to be problematic, because the default is normally QPSK. If you look at your modulation profile, you're going to see QPSK for station maintenance and initial station maintenance. Changing that to 16 QAM, it fixes so many things. It makes your system run so much better. It's
funny, it's like you're making it less robust, but you're actually getting it closer to what the data is really running.
Yeah.
You know, if I had my way, people would come back to me and say, well, why don't we just run 64 QAM for the maintenance of the modem to match up with 64 QAM with the data? I'm like,
the chip
because
doesn't support it.
yeah, the chip doesn't support it. Exactly. That's what it is.
Yep. Yeah. And so it's something that I really, almost every system I work on, it's one of the first changes we make is to change that mod profile from QPSK to 16 QAM. So
yeah, that station maintenance burst affects ping DOCSIS versus ping. It affects the flap list. It affects potentially levels and MER readings.
it affects pre-equalization.
It affects pre-equalization. I got to add that one. I knew there was one more. And it affects the upstream bonding partial mode. So there's 5 things that station maintenance burst is affecting.
Yeah, when we put a PNM system in, we will see, you know, say out of 1,000 modems, we'll see 200 modems that are red, and then we change from QPSK to 16 QAM, and those 200 red modems will double to 400 red modems. So it really changes pre-equalization as well.
So now I have to. I knew
taking notes.
Yes, I am. You believe that? Because I knew there was another one I kept forgetting to throw under my list of what that really does affect. Because that's the whole reason why we changed the preamble on our IM and SM bursts, because the pre-equalization is based on the preamble of those bursts. So we need a longer burst to get a good reading. And if it's too short, we don't get a good reading, and we have fluctuating MER readings, and the pre-EQ doesn't track correctly. And
yeah,
okay.
So you touched on DR when you're talking about ranging status message. We have a question from I think Aslan. I hope I'm pronouncing his name right. He says, "What does DR mean in ranging status, and also what does DI mean?"
So the DR. So if you do show cable modem with the MAC address and verbose. Verbose obviously means everything, right? So you get everything.
We're verbose.
Yes, I'm very verbose. Gregarious.
Yes.
Throw some more bombastic words at you. So under that verbose output, you'll see all the upstream channels and the levels and the MER, the max power, everything for that modem's upstream and downstream and service flows. And it should say STA, meaning the current state of every upstream is STA, meaning it's doing station maintenance. If it says DR, it's basically disabled, and it's R means ranging. So it's disabled with continuous ranging. Because there's another state called CONT, which I think is continue, but it might end up in the DR state anyway. And DI was disable. I'd have to look it up again. There's a chart of what all the letters actually mean. Did I give the answer in the when you asked this before?
Yeah.
Because I might have looked it up and.
I'm looking to see if it's here, but I don't see what DI means. You have Dora here, your normal discover, offer, request, acknowledge, NIT, a NIT-IO, a NIT-DR, and a NIT-I to indicate those 4 stages of registration.
Yeah. We need a new mnemonic for DOCSIS 3.1, right? I don't think it's Dora anymore. Is it? Because it's I was going through some training with this before. I don't know if it's 3.1 or something else, but it's not just discover, offer, request, acknowledge for DHCP. I have to look that one up. We need to come up with some more acronyms and mnemonics. All right, move on to the next question.
Okay, so from Anil, he says, "Hi, normally we do amplifier balancing in DOCSIS 2.0 with a single frequency at 22 megahertz at an RF level of 20 dBmV at the return input. In DOCSIS 3 with 4-channel bonding, what could be the balancing technique? Do we need tilt? How do we do this? What changes from DOCSIS 2.0?
This is upstream?
Yes.
Upstream. Yeah. So, I mean, because DOCSIS 3.0 on the upstream is not like 2.0, I mean, it's not like 3.0 on the downstream, meaning there is no primary channel. On the downstream, we have a modem locks onto a primary channel as its control channel, and then it bonds across all the channels as part of its bonding group. On the upstream, we do station maintenance with every single upstream channel that modem is using. So this actually adds what I call more availability and reliability on the upstream, because if I lose one of those upstreams, he's still doing station maintenance on all the other upstreams, so he never goes down. So it doesn't matter if I lose one upstream or 2 upstreams, the modem, as long as one of those upstreams says STA, that means it's going to stay online. So when you look at balancing, the levels are still doing station maintenance on every single channel independently. So if I go to 4-channel upstream bonding and the modem's transmitting, say, 40 dBmV at one frequency, it should be transmitting 40 dBmV at all the other 3 frequencies as well, because they're all independent upstreams. Now, the problem comes in when you start hitting the max output, because we know when we do 64 QAM, 4-channel upstream bonding, 51 dBmV is the max. So if I go from 2-channel bonding to 4-channel upstream bonding and your levels are under 51, they won't change. Like a lot of people think you drop 3 dB. The modem transmit levels don't change by 3 dB unless you hit the maximum ceiling. So if I'm at 2-channel upstream bonding and I'm off a 23 dB tap and the modem is transmitting 50 dBmV, well, if I go from 2-channel to 4-channel, all 4 channels will transmit 50 dBmV. It won't drop to 47, 47, 47, 47. You understand?
Yep, absolutely.
Because it'll go 50 for each one, and they're all under 51, so it's still legit.
And your return, it's still a unity gain. It's
exactly.
It's still
the
like
loss. The loss from modem to CMTS hasn't changed.
Yeah.
So it's looked at each upstream independently.
Yeah. So I think, I mean, for balancing for DOCSIS 3.0, it's still like balancing for DOCSIS 2.0.
Correct. Correct.
So you could do this with a tone, which is the way we used to balance the returns.
Yeah.
Same way.
You would shoot for unity gain, and whatever you really wanted to run in your cable plant, you could manipulate the cable modem levels by just manipulating padding in the head end.
Yep.
You know, the modems will have long loop level control. They'll just jack their levels up to hit the CMTS at 0. So if I just change padding in the head end, that's what's going to dictate what really hits my amplifiers.
Yeah, and I got to tell you, a lot of times when I'm working with customers, especially ones that don't know much about balancing their returns, I will a lot of times have them just adjust padding at the return path receiver to optimize the SNR, MER of the modems coming back in, because I know they don't have the capability to go out and rebalance their return. Yeah. But if the modems have, if we can adjust the padding so that we can get a really good SNR from the majority of the modems and a good upstream transmit power from the majority of the modems, then we've achieved relative success. So. Yeah,
I mean, you think about it, the limiting factor, like we always talk about, is probably the analog optical link. And if I can hit that hotter, then you'll probably get a better MER. And if you put more, it's funny, it's like if I could take padding from the head end and put it in front of the laser, the upstream laser, that would be probably even better.
Oh, absolutely.
You're not changing anything, but by moving padding from one point to another, you're changing the OMI of the laser potentially, because you're getting less noise into the laser.
Yes. So, okay, we'll do one more question here, and we have to take this one because if we don't, our friend Brian Wilson will give us problems, and he has an interesting question. We need to get him back on the show here, or he's probably going to ask crazy questions like this again. But his question is, where do you see MSOs going in the next 36 months? XPON, or some sort of PON, or DOCSIS 3.1. So this is definitely a
prognostication.
Prognostication. Bring out your crystal ball type question here.
Let me bring out my procrastination on my prognostication.
Oh, procrastinate on a question.
Fine, I don't appreciate that one. So where do we think MSOs are going? I wanted to have a funny answer to that one. They'll all be retired by then. Where are they going? This is part of the analysis paralysis, right? I mean, I really think if you're a publicly traded company, Wall Street kind of dictates what you can and cannot do. Your stockholders are going to, no, we're not doing that if you're going to spend $1 billion on an HFC plan upgrade. If you're going to do an HFC plan upgrade, why don't you just do fiber now? If we look at all the numbers to do fiber, we probably could just look at what is it costing Google and Verizon's Fios. Are they really making fiber ubiquitous everywhere, or are they just cherry picking where they know they can get good money? Just like you talked about the AT&T stipulation of you can't just pick and choose where you want to offer your services. You have to be able to offer it to maybe everywhere. So it's going to cost more money. And everything comes down to money. I mean, if money wasn't the object, we'd run fiber right to everybody's, I say eyeballs. You know, you would do holograms in the house instead of TVs and everything else, and you just run fiber in. But money is where it's at. HFC plant is what we have. We're going to exploit that as long as we can. We're going to keep going to that cash cow, and our return on investment is we have to keep investing to keep it up. But I can see nodes dropping smaller and smaller, but not RFOG everywhere, not GPON, EPON everywhere. I think remote PHY has some great advantages. When you and I talked about upstream, 85 megahertz, 204 megahertz upstream, 85 megahertz upstream, I think makes a lot of sense in the case of a lot of legacy set-top boxes in the everywhere, especially in the US. They have a downstream addressability channel at like 104 megahertz. So we are looking at an 85 102 megahertz split. Some people are quoting 85 105, but we actually had to cut it down to 102 so that downstream 104 could still work. 85 megahertz upstream to me makes a lot of sense because I doubled my upstream. I can fit at least 8 ATDMA channels in there. I can timeshare it with DOCSIS 3.1 and get potentially, I did the math on this, if I can get to 256 QAM upstream with DOCSIS 3.1 and I slice it up into 6 megahertz and do 13 times 6 is like 78 megahertz. I can fit it in 585. I can run different modulation at different subcarriers in case my noise floor is not flat, which it won't be. But I can get close to 470 megabits per second. So that right there could offer a 250 megabit per second service on the upstream. That should be enough to offer a 2 gig service on the downstream, if not more.
Yep.
So if I do that on the upstream 585, and then I say, all right, my downstream, I'm not going to upgrade 750, 860 to 1 gig. Why would I do that? Go right to 1.218 gig. That's in the DOCSIS 3.1 spec. Yes, I would have to change out taps. I shouldn't have to change out coax, I would hope. Depends on how bad the coax is, right? If it's a little waterlogged, you're going to have more roll off on the high end. But a clean coax should go well past 1.218. I do have to worry about MoCA channel D1 at 1150. So that's something we have to keep in mind is if I'm using.
Yeah, we have filters for that. So
yeah, exactly. So you bring it up, but then you have to make sure that people know how to deal with it. You throw in some DOCSIS 3.1 on the downstream. You extended your downstream. You do analog reclamation. I thought another funny term was digital reclamation. Not only reclaiming analog, but taking the MPEG-2 and squeezing it to MPEG-4. If not, what some people call MPEG-5, HEVC, which is H.265.
Yes.
I think it is.
Yeah.
So it's even better compression. So you go from a legacy set-top box to an IP set-top box. So here's where we're talking more money, right? The CPE is more money, changing out all the set-top boxes. So maybe you don't do that. Maybe you don't need to do analog and digital reclamation because you went to 1.218 gigahertz. You know there's going to be more attenuation, so maybe your nodes had to drop to node +2 or node +1 or node +0 even. If you get down to node +0, you could do remote PHY and get even better MER and do higher modulation schemes with DOCSIS 3.1. Remote PHY is taking the CMTS chipset and put it in the node itself. So it's Ethernet. It's Ethernet to the node.
Yeah, and that's something that I think we've discussed before, that we need to get rid of the analog optics in the return, and especially if you're going out to 85 megahertz or 200 megahertz, that's a requirement. Yeah.
And if I went to 204 on the upstream, because of the loss of coax, because of thermal fluctuations, I cannot see us getting around doing a 204 diplex in any N plus X architecture. Meaning I could see a 204 megahertz upstream if there's less coax. Meaning I could see a 204 upstream in an RFOG, in a remote PHY node +0, even a regular node +0. A 204 is probably doable. You understand why, right? Because less coax. Yeah. Much less coax. If there's a lot of coax, you're going to have thermal swing. The levels can change more than people think. That's part of my speech for the expo coming up in October. Is even looking at 85, we see potentially plus or minus 5 dB swing. That's 10 dB range from the modem.
Yeah, you need a lot of thermal compensation or an AGC in your return then.
You know, I thought about Upstream AGC, and I'm thinking, how would you get a continuous carrier on the Upstream? What would you track?
You need to put a pilot in return.
End of line. Every end of line, you need a CW generator hanging off the pole.
That's crazy. You know, you can do that with a modem. I mean, a modem could generate a pilot. It's just that you don't want to do it.
we could just balance off the internal ingress we always see.
Yeah. AM.
Yeah, AM radio. AM radio. Oh my gosh.
So you know, from my point of view, I think the good thing is that the cable operators have a lot of opportunities. They can extend their existing HFC with DOCSIS 3.1. They have RFOG and they have PON for greenfield applications where they're already doing that right now with both EPON and GPON. So yeah, there's a lot of opportunities.
What I see is like EPON, GPON, and even DOCSIS provisioning over EPON or GPON being cherry picked, meaning if you have only 5 subscribers in a fiber node, that's easy pickings. You know, I will cherry pick those and give them GPON. And I even have my customers, MSOs, cable companies, doing GPON for data and RFOG for the video, because they still got to get video out there too.
Yes. Yeah, and that's not. Yeah, that's an overlay, or you can go with Dish or DirecTV or something. So
Ixnay on a dish.
Yeah. All right, John. I think this is our longest show yet. I think we've covered everything and a lot of questions. I want to thank you for your time. Thanks everyone for joining, and we'll call this one a wrap. So,
all right, pleasure as always.
All right, take care, John. Bye.
Yeah, bye.